Hello everyone, welcome to my channel. This is Cracking LeetCode from Scratch, episode 2, which is also the second problem on LeetCode, add two numbers. This problem is about a singly linked list. Let's look at the problem first. It says, given two non-empty linked lists representing two non-negative integers, each of their nodes contains a single digit. Especially, the digits are stored in reverse order. At last, it says the two numbers do not contain any leading zero except the number 0 itself, which means all the input numbers are regular and valid. Okay, let's take an example. 9,876 plus 589, that is 9876 plus 589. For this problem, the input lists are like this. We can see the digits are in reverse order. Of course, the output or the sum 10,465 also should be returned in reverse order. 56401. Next, let's quickly review the mathematical process of two numbers addition. First, we add the digits in the ones place. 6 plus 9, we get 15. So we let 5 in the ones place and the 10 or the carry 1 was regrouped with tens place digits. Then we add the digits in the tens place and the carry. 1 plus 7 plus 8. We got 16. Similarly, and place by place, we get our final results. 10,465. Till now, we can notice that the list's reverse order occurs with addition's operating order. So we get the main idea of this problem's algorithm. That is, we can add the two numbers while iterating the two input lists. Next, let's coding. This is the first part of this implementation. First, we define pointers P, Q, which refer to the input lists L1, L2, and the result list res, which will be returned at last. Then we handle the common section of the two input lists. Because the length of input list L1 and L2 may be different, so actually the length of the common section equals to the length of the short one. About this part, we focus on these three-line codes. First, we get the sum of one place's digits plus carry, and second, we get the result digit value by sum modulo 10, and then we get the carry by sum divided by 10. And next, we'll allocate a new list node to save the digit value and then link it to the tail of the rest list. Let's take the example above to see how this runs. First, we handle 6 plus 9, we got 5 and carry 1. And then 178, we got 6 and carry 1, and go on. We got 4 and carry 1. Till now, the common section is done. Then we get to the second part of this implementation, which handles the remaining part of the longer list. Because we don't know which one of the lists is longer, so we write two for loops. If L1 is longer, like this example, the first for loop will be executed. Otherwise, the second will be executed. Okay, let's continue the running. The remaining part here only contains one node. So if there's more, P will go to next till the last node. At last, we get to the third part, which handles the last carry. For this example, the last carry equals 1, so we need an extra node to save it. Okay, this is the first implementation. About this version, there are 2 points that actually can be optimized. The first is, we don't need extra space for res. Instead, we could use input list space. And second, we can simplify the second part's code. As we've seen, the two for loops are very similar, so we could do some simplification, which we'll see later. After these two optimization, we get our second implementation. This is the first part. We can see, after the calculation of the result digit value, we save it directly to the L1's nodes without allocating any new space. Let's take the same example to see how this runs. But a little change. We let P refer to the short list and let Q refer to the longer one. Also, here you can see the pointer pre is defined, which refers to the previous node of P, which we'll see later what's this for. First, we do 9 plus 6. We got carry 1 and 5, which is directly saved to the first node of L1. And then the second and the third, and then the common section is done. We get to the second part, or the second simplified part. Here's a if statement to check if L1 is shorter. If it is, we'll switch P to L2. Next, let's see how this runs. This is a state after handling the common section. Look carefully, the switch happens. We can clearly say the shorter list and the remaining part of the longer list are linked together, and the P refers to the first node of the unhandled part. Continue running. Again, there's only one node to be handled for the remaining part. If there's more, P will go next till the last node. And last, the third part handles the last carry. Carry equals 1, so we need extra node for this carry. Okay, above all is how we solve the problem to add two numbers. Next, let's do a little conclusion and reflection. In future, we'll run into some more similar problems that handles two input lists or two input arrays. For these problems, we can think of this coding pattern first. The first part, we deal with common section, and the second part, we deal with the remaining part of the longer one. Of course, sometimes the second part can be simplified, and similar to those with two input arrays. Finally, here's a little question. For this problem, actually there's another idea. First, we transfer two input lists to two numbers, num1 and num2. And second, we get the sum of num1 plus num2. At last, we transfer the sum to list and return it. It seems okay, right? However, this doesn't work for this problem. You could try. But if we really want to make it work, how will you modify the constraints of this problem? If you got something, please comment below. I really appreciate it. Okay, thank you for your watching. If you liked this video, please give me a thumb up and hit the subscribe button. See you next video. Bye.